All right, good day, everyone. My name is Christopher Pogome. You are welcome to the Chem Lab Chemistry Mastery Academy. Today, we're going to be looking at the topic gas laws. And basically, or specifically, we're going to be looking at Boyle's law and Charles' law. Now, what is Boyle's law saying? Now, Boyle's law says that at constant temperature, the volume of a fixed mass of gas is inversely proportional to its pressure. Now, Boyle's law considers the volume of the gas and the pressure. Boyle's law is saying that when you increase the volume, the pressure will reduce. When you increase the volume, the pressure will reduce. When you increase the pressure, the volume will reduce. Are we following? So that's why I said, as long as the temperature remains constant, as long as the temperature does not change. So at constant temperature, at a temperature that is not changing, okay, the volume of a fixed mass of gas, the volume of the gas that is fixed is inversely proportional to its pressure. So for example now, if the volume is 25 cm cube, automatically the pressure will either be lower or be higher. The pressure cannot be the same. Are we following now? For example, you take balloon, right? Now, that balloon that you took, if you look at it, is when there is no air inside, it's small, right? That's the volume, isn't it so? Now, by the time you start blowing air into the balloon, what's happening? The volume is increasing, right? The volume will be increasing, right? By the time you start blowing air into the balloon, right? Good. Now, we said the volume of a fixed mass of gas is inversely proportional to its pressure. Now, when you blow air into the balloon, now the balloon is now blown, right? It's now filled with air. The volume is now increased, right? When the volume is increased, how much pressure is on that balloon? Is there any pressure on that balloon? The pressure on the balloon is very low, right? Why? Because the volume is high. Is it not so? But by the time I press the balloon, increase the pressure, what will happen? The volume will reduce. Is it not so? It will burst, right? That's a typical example. That's a typical example. So when I apply increased pressure, what happens to the volume? The volume will become smaller. Are we following? That's a typical example of application of Boyle's law. Now, let's look at the mathematical expression of Boyle's law. So, we said we're looking at Boyle's law. Looking at Boyle's law. And now, in Boyle's law, we said that at constant temperature, unchanging temperature remaining the same, the volume is inversely proportional to the pressure. Inversely, that is, we have reciprocal of the pressure. Okay, so this is the mathematical expression of Boyle's law. Now, this mathematical expression of Boyle's law can be worked on even further, such that when we introduce a constant of proportionality, we have V, this proportionality sign changes to equal to 1, changes to K over P. Now, what's cross multiply We now have K, which is a constant, is equal to what? P times what? V, which is PV. Okay, so what that means is this. K is equal to what? PV. And K is a constant. That means there is a pressure and a volume, which is the original pressure and volume. Now, when you now begin to change the what? Pressure. When you begin to change the pressure, that means you are introducing a new pressure, right? So as you are introducing a new pressure, a new volume will also be what? Introduced. So in this case, what we are looking at now, we are saying that we have an original pressure and original volume, and we have a new pressure and a new volume. Are we getting it now? The new pressure and the new volume is the one that you get when you change the original what? Pressure and what? Volume. Are we following now? So this formula now becomes P1 V1. P1 is the original pressure from the onset, from the beginning. V1 is the original volume from the onset, from the beginning, equal to P2, that is the new pressure, V2, the new what? Volume. Okay, so when we increase the pressure now, there is a new volume that will also be what? Will formed, right? The volume will reduce, isn't that so? So that increased pressure is the P2. While that reduced volume, as a result of that increased pressure, is the what? The V2. So this is the mathematical expression of Boyle's law. All right, thank you. Let's look at Charles' law. Now, you would remember or you would note that in Boyle's law, we considered what and what? Pressure and what? Volume. Isn't that so? Now, in Charles' law, what are we considering? In Charles' law, we are considering the volume and the what? Temperature. That's what we are considering in what? In Charles' law. Now, what is Charles' law saying? Charles' law says that when the pressure is constant, when the pressure is not changing, the volume will increase when temperature what? Increase. Charles' law says that when the pressure is not changing, the volume will increase as temperature what? Is increasing. So Charles' law, at constant pressure, the volume of a fixed mass of gas is directly proportional to its temperature in Kelvin. You get it now? So let's see. Which example can we use now? Let's see. Something that the volume is increasing as temperature is what? Is increasing. When you are boiling water, and as the temperature is increasing, what will be happening to the water vapor that we produce? Will it not be increasing? It will be increasing because as the temperature increases, before it gets to the boiling point, as the temperature increases, what will happen? More vapor will be produced as a result of the more the water is what? Is boiling. Are we getting it now? So as temperature increases, the volume of the vapor, which is gas, will also what? Increase. Are we getting now? That's why you notice that when you increase the heat in your boiling water, what happens? You have more bubbles being produced, right? And more vapor coming out. Is it not so? Good. All right. So now let's look at the mathematical expression of Charles' law. You deserve the glory and the honor. As we lift our hands and worship, as we bless your holy name, you deserve the glory And we are now. All right, Charles Law. As we lift our hands in worship, as we bless your holy name, you are great, for the miracle so great. Now, in Charles Law, we said when the pressure is constant, when the pressure is not changing, the volume of the gas is directly proportional to the what temperature. So the volume will increase as the temperature is increasing. Or the temperature, when increases, volume increases as well. Exactly. Or as the volume is reducing, temperature reduces. Or as temperature is reducing, what happens? The volume will be what? Reducing. So as you are reducing the heat, the amount of water vapor that is being produced will also be what? Will be what? Reducing. The rate at which the water will be boiling will also be what? Will be reducing. Okay, so V directly proportional to what? T. So now V equal to what? KT. Then we have, making K the second formula, we have K equal to what? V over what? T. We divide both sides by T. So we have K equal to V over T. Remember we said something the other time concerning Boyle's law, that we have original volume, we have original what? Temperature, right? And then when we increase one, automatically the other one will also increase, forming a new temperature and a new what? Volume. So V1 over T1, that's the original one, equal to V2 over T2, which is the one that it changes to. So this is the mathematical expression or statement of what? Charles law mathematically. Exactly. All right, thank you very much.